the factored form of a quadratic function. Okay, there are three commonly used forms of quadratic functions. You have been introduced to two of these forms. What are they? One is the standard form and the second is the vertex form. And the third common form is referred to as the factored form. Right, so standard form, as you already know, that the standard form of a quadratic function is f of x is equal to ax square plus bx plus c. Okay, now whereas the vertex form is f of x is equal to a times x minus h whole square plus k. Here this h comma k makes the vertex, that's why we call it as the vertex form. And the third is the factored form. Today we are going to look at that factored form of quadratic function. It is f of x is equal to a times x minus r1 times x minus r2. This is the third type. Okay, the standard form is f of x is equal to ax square plus bx plus c. The vertex form is f of x is equal to a times x minus h whole square plus k. And the factored form is f of x is equal to a times x minus r1 times x minus r2. Remember here this a, here this you have your this a, b and c. These are the constant numbers like 5, 12, whatever constants, the values. Here this a, h and k, they are also numbers, and this is a, r1 and r2. They are all real numbers in fact. Okay, so only x is a variable here, and f of x is the value of this function, and it goes in the y coordinate. We know that y is equal to f of x. Okay, we can see it later. Now, each of the quadratic functions below is written in factored form. So we have few problems here, and use the graphic calculator to graph each of the functions, and make sure that you choose a graphing window that gives a complete picture of the graph of the function. Copy the graph of each of the function on a separate graph paper, and use your graphs to help you discuss what the factored form of the quadratic function might tell you at first glance. So the first problem here is f of x is equal to x plus 3 times x minus 4. So our task is to draw the graph of this function using graphic calculator. Then we also have to draw it on a graph paper, and afterwards what information, what you understand from the graph of this function, we have to tell that. Okay, now let us go to graphic calculator. So we have here, let me clear off everything. So I'll hit the second and plus sign, go to 7, then 1, then 2, that's it, everything clear. I hit enter. Now let's go to y is equal to, this y is here, start the parentheses, x, then plus 3, close the parentheses, and again open, x, this is my x, minus 4, close the parenthesis. So you have your function y is equal to x plus 3 times x minus 4. Now let us hit the graph. Okay, this is the graph. It's almost perfect, but the bottom part is missing. So we have to go down some more. So the better way of looking at those numbers, how far I have to go, is to just check my table. How do you do that? I'll hit the second that I already did and the graph. That is, it gives you the table. Okay. So now on this table here, starting from 0 for x values, you are seeing some negative 12, then 10, then 6, etc. And the high values are 18. You are seeing, let us go a little bit upwards and see if any uniformity is there. See, I am seeing some repetition here. 6 and negative 6, negative 10 and negative 10, negative 12 and negative 12. And let me go some more up and see if I get 0. Yeah, 0 is there. Likewise, some suitable numbers. So you are seeing, and eventually, like at this point, negative 12 and next number also negative 12. And afterwards it is negative 10. That is, it's going down. This graph went all the way down to negative 12 and further, and then went up. So it's not way beyond negative 12, but is little closer to negative 12. Therefore, my window, we will select this. I'm thinking that it's in the middle. This 12s. Up we will take some 6 numbers, like let me take up to this 8 value, that is negative 4, and or negative 5, that's fine. And then this side I'll take 6. So the window for x values, I'll take negative 5, maximum minimum value. Maximum value will take 6, then scale is 1, then y minimum value, we have seen that negative 12, right? Over here, negative 12 is around, negative 12 is the least number. So let me just take minimum value as negative 15, right? I'll take negative 15, and then maximum value, let us take something like 10. That much is enough, I think. Scale 1 and resolution 1. Hit the graph now. Now we see a perfect graph, right? This graph is clear. It has so much information in it. We see where this graph is intersecting the x-axis. Alright, this is the point x-intercept and the y-intercept, and the least point, that is the minimum value for y. Everything is clearly seen in this graph. Okay. Now, according to the task, they are asking us to draw this graph on a piece of graph paper. That is, we are going to redraw this graph again. I'll show one of these, and then we'll try to continue to see its characteristics and go from there. Okay, let me show you this graph by taking the values from the table. I'm not going to calculate all these values like we used to do, because I already have the table, and I'll start taking the numbers from x is equal to negative 4 and all the way up to x equal to 5, and draw the graph on the regular graph paper. Okay, let us see. Okay, now I have this f of x is equal to x plus 3 times x minus 4, and x and y values I'll just note them down here on my chart. We'll start from -4, right? -4, then -3, -2, -1, 0, 1, 2, 3, 4, and 5. And what are my values? For -4, it is 8, then it becomes 0, -6, -10. We have already seen that in the graph on other graph calculator also, right? So 10, then 12 for 0, -12 for 0, again -12 for 1, then for 2 it is -10, then -6, you have for 4 it is 0, and 5 it is 8. You can see that the first and the last 8 and 8, 0, 0, 6 and 6, they are all matching. Now I have to locate these points in our regular graph sheet. I have it right there. Let us now, here x values are -4 to 5 we need, and the y values are, the maximum we have 8 and the minimum is around 12, right? 12 or little down we'll go, and let us calibrate this. I can take 2 units on the x-axis. I think 1, 2, 3, 4, 5. 2 lines I'm equating to 1, so all the way 5 you have here, and this is 1, -1, -2, -3, -4, -5. And on the y-axis I need 8, so I'll just take 1 at a time, only 1 unit. 1, 2, 3, 4, 5, this is 5, just disregard, 6, 7, 8, 9, 10, and down 1, 2, 3, 4, 5, -5, 1, 2, 3, 4, 5, that is -10, then 1, 2, 3, 4, 5, -15. Okay, let us quickly enter these numbers. Alright, when x is -4, the value of y is 8. -4 is going to 8. -4, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's right. Then -3 goes to 0. This is -3, 1, 2, 3, goes to 0. -2 will take -6. This is 6, that is -2. So 2 here, 5, 6, -6. Then afterwards -1 will take 10. This is -1, take 10. I can also use my ruler if I have to, that -1 and 10. You are here. Then 0, this 0 is taking 12, 10, 11, 12. After 0, 1 also takes 12. This is 1 and 12 over here. Then 2 goes to -10. 2 and -10. 2 and -10. Then 3 goes to negative 6. This is 3, that is negative 6. 4 is 0, right? 4 and 0. Then 5 takes 8. 8, 5 is here, this line, let me not miss it, and 8 there. So these are my x and y values, and you got the points plotted in this graph. Okay, now let me connect all those. I'll just can start up from here. Here, this is because it's a curved graph, it is a parabola. You'll have to turn it around and make sure that you touch all the points, and it goes further. So I'll just put an arrow there telling you that it is extendable. Now this is the perfect graph that is obtained. Alright, let me, this is the graph. Now what are the things that you can observe through this graph? The most important thing is like your x-intercept and of course this y-intercept. This graph of the function f of x is equal to x plus 3 times x minus 4 is intersecting the x-axis at where? At x is equal to negative 3. When the value of x is negative 3, y becomes 0. And similarly here, at x is equal to 4, the value of y is 0. So, your x-intercepts are negative 3, 0 and 4, 0. These two are the x-intercepts. And similarly, this y-intercept, when x is equal to 0, here this x value, from here all the way, it is, the value of y is 12. So the y-intercept is 0, negative 12. That is the y value, 0, negative 12, you see. And I have also drawn a straight line here that is passing through the minimum point. And that straight line, we call it as the axis of symmetry. And the graph, sometimes if you have a negative sign here, it goes upside down, and you don't consider it right now. But I have here, this is the graph, x-intercepts, y-intercept, the minimum point. That minimum point, we call it as vertex. This is the vertex minimum or maximum point where the graph is upside down. We'll get there. Okay. These are the things that are seen in this particular graph. Alright. Now let us continue to the next graph. Now the second function is f of x is equal to 2 times x plus 2 times x minus 5. So let us go to the graphic calculator. I think I have it already. I started off. So f of x equal to, that is y equal to 2 times x plus 2 times, I'll close the parenthesis and again open, x minus 5, close the parenthesis and hit the graph. Oh, this graph is also all the way down. Let us look at the table now. How did you get table? Hit second and graph. Now the values of y, here it is negative 20, negative 24, and again it became negative 20. That is, it is going up. Negative 20 is greater than negative 24. So negative 24, somewhere here we have our minimum values. So I'll go to the window and take x equal to, let me take around 30, negative 30. And the maximum value for y, it will be I'll just take from 10 like that. 16 is also too high. And the values for this, I'll start up from -3. For x, go all the way up to where? Here, 6. Right? I'll start from this -3, go to 6. Window, -3, enter, 6, enter. Scale is alright with 1. Y minimum is -30 we thought, right? And the maximum is 10. Let me go back to the table to double check. And the scale, we can have 5 as the scale. That is, it is going up by 5s. And let me go to the table to make sure. See, I'm looking for y value, maximum 10. And minimum is around 30 because of this 24. Okay, everything is set in the window. Now hit the graph. Just it is trial and error. If your graph is not looking good, we don't have to worry. Just go back and fix your window. Now this graph is almost perfect, right? Alright, then like I showed for the first problem, all the characteristics using this regular graph sheet you can draw, get the table and all that. But here I'm not wasting your time. I'll just talk about its characters, x-intercept, y-intercept, and turning point, etc. Now you can see that the graph is intersecting the x-axis at -2 and positive, how much? 1, 2, 3, 4, 5. X value -2 here, and that x value is 5. And if you want to write the x-intercept as an ordered pair, -2, 0, and here it is 5, 0. And what is the y-intercept? Over here, for x is equal to 0, what is the value of y? How much it is? We went up by tens. So if I don't know exactly what it is, I'll just go to my graph and look at the table. For 0 it is -20. That's what we see here. When x is 0, y is -20, -5, -10, -15, -20. That is my y-intercept. Right? These are the things you can see. Now later on you are going to learn how to figure out, get these values directly from the function. But right now we are depending on this graph to talk about all this. And you also should know how to draw the graph in the regular graph paper. Okay. Now let us go to the third one. The third says it is half times x plus 3 times x plus 3. Okay. I'll have y is equal to 1/2. I just cleared off here. 1/2, we can just write it as 0.5 or just 0.5. 1/2 is nothing but 0.5. Parentheses x plus 3, close the parentheses, again open, once again x plus 3, x plus 3, close, hit the graph. It is not at all clear. Let me look at the table. We are seeing that the repetition of the y values is taking place here. See, 0 is in the middle, 0.5 and 0.5, right? And then 0.2 and 2, then 4.5, 4.5, etc. So we can take somewhere around this for x values. and the y's are also not very high, and we are seeing all positive values for y. So you don't have to take that much negatives for y. Okay, x -6 we start out, and I'll go somewhere around 2 because x value here up to 0 also can stop, just 2 extra I'm taking. And similarly y values, like I said, there is no negative y, just go down to -2, and positive values, maybe I'll take some 6 like that. Let us see. To scale is 1, that's okay, just -2 like I said. I don't need any y negative values. In fact, maximum either 6 or even 10 is okay, but so let us see what happens when it is 6 and the scale is 1. Hit the graph. Right. So this graph gives us some information regarding the function f of x equal to this 1/2 x plus 3 times x plus 3. So I'll go to the next page, and in that we'll draw the graph. And yeah, let me see here. Okay, this is the graph, and you can see that it is intersecting x-axis at this particular point only at x is equal to -3. That's the only point that it came reached here and went up. So -3, 0, and the y-intercept is somewhere here, like 4.5, or let me see with the calculator. I'll hit the second and the table. You're seeing that when x equal to 0, y is 4.5. The other way of finding this y-intercept is just go to the calculate, that is second, and hit trace. Find the value at x is equal to 0. Even that gives us the y-intercept. Okay, so y-intercept, x value is 0 and y value is 4.5 we have. And one thing we have to think, why the graph turned from this point. It touched the x-axis at -3 and went up. And the previous ones, the previous case here, we have seen that what happened there? In the second case, when the graph is intersecting the x-axis at -2 and also 5. It has something to do with these numbers. That's what you can observe. X plus 2. So my x-intercept is at -2. X minus 5. So my x-intercept was at a positive 5. Also, in the next page, we have seen that it is intersecting because the two are repeating. Maybe that's the reason the graph turned around from this point. It touched the x-axis at -3 and turned around. And also in length, we discussed about the first graph we have drawn and seen the graph for the first one also, right? Through that regular graph sheet. Okay, these are all the things that we have to observe from this graphs of a quadratic function written in the factored form. What is the advantage of having a quadratic function written in the factored form? So these factors are helping us to know something about the x-intercepts and also the y-intercept. When I change the value of x to 0, you will just get the y-intercept, and many more features that you can see as we proceed. Okay, so you please try the problems that are given to you. In your packet, you have different numbers for this A, B, and C. So please draw and try to find the x-intercepts, y-intercepts, and if you can find the minimum point, axis of symmetry, the minimum point, please say it as a vertex. It is the vertex, and the other features, what all we can find, we can find. Okay, thank you. Thanks for watching.